In this video, we provide an example of generating a custom waveform using MBScript and loading it into the waveform source. MBScript is a C-like language provided with the software. For more information about MBScript, you can open the reference manual under the Help menu in the System window. Here is the example script we will run. Let's walk through the lines to see what's going on here. First, we add some libraries, standardlib.mbs and wslib.mbs. Each of these provide functions which make writing code for the waveform source easier. We define some constants. Fundamental frequency is 1 kilohertz. Number of points in the waveform, 630. And then the period for each point is just 1 over the fundamental times the number of points. Next, we define a function, wave value, based on degree. So we pass in the current phase of the waveform, and then we calculate a waveform voltage for that phase. We first add 2.5 volts, which is the center of our waveform, and then we add the fundamental, and then the third harmonic, and the fifth harmonic, and the seventh harmonic, and the ninth harmonic. Next, we open the waveform source window if it's not already open, and we generate the waveform points. So for I equals 0 to the number of points, 630, we will generate a phase value, I times 360 degrees divided by the number of points, and then we'll call the setPoint function, which will calculate our actual voltage for that phase. Finally, we create one additional point at the last point location, and that point includes a jump back to the beginning of the waveform. We have to configure that jump A, always back to location 0. Next, we update the display of points in the waveform, and then we start the waveform output. This waveform has been saved as WS Fourier Square appnote.mbs. To run the script, we go to the System window and click Run Script. We find our script, WS Fourier Square appnote.mbs, and click Open. Once the script has completed executing, we can see now that we have a square wave made up of the fundamental and multiple harmonics.